In this video, I want to run through a fun little 3D model that a customer brought in a few weeks ago. And this will also supplement nicely, I think, a video that IGEMS did about 3 weeks ago. If you go to their IGEMS YouTube page, they've been uploading a lot of nice videos recently. They've got this one here, Modify 3D Geometry, which will be somewhat similar to what I'll be going through here, although a little bit different part. So you can take a look at this one for any other ideas. So of course, for any sort of 3D file that we want to open up, want to go into the 3D-5X module, and then IGEMS menu, open, and we've got this step file here. So here's the part. Right now this part is programmed for 3/8 thick material. I actually want to cut it out of some 1/2" aluminum. So first thing I'm going to do is scale this up on my CAD tab, and by the way, your tabs might be in a little bit different order than what I've got here. I've got my customized toolbar on here, but CAD tab should be pretty similar. And so CAD tab, you can do things like under the transform submenu here, you got the scale option, and brings this box up here. So what's kind of handy about this box is you can do math. So if you don't know the factor to go from 3/8 thick to 1/2" thick, I can just type that in. So 0.5 divided by 0.375. And if I go back to the IGEMS menu properties, I can now see that my Z height of this model is 1/2". And first thing I always teach people is to move that 000 point to be somewhere on the top of the part, since all of our Z coordinates are typically referenced off the top of the material. It's always a good habit to get into Cam tab, first thing, 0 point, and especially nice on a part like this where you don't have a square corner to easily click on. If I right click, I can choose this box option, draws a 3D box around the model, and then I've got my snaps on already. If I don't have my snaps on, down here in the corner you got your snaps, and you can choose your default snaps, and I'll just put my 0 point at the lower left hand corner of the top of the part there. So next we're going to have to figure out how we're going to attack this. So what makes this one a little bit interesting is we've got some missing edges here. So for example, on this bevel cut here, which is essentially a fixed bevel, but we're swinging the C-axis around as we're going around here. We could pick, for the top edge, we could pick this edge, we could pick this edge and go like that, and then correspondingly choose this as our bottom edge. Sometimes when you get into an area like this and it hits this change in the edge, you might get a little bit of a movement in the A and C. So for best results, you can basically draw in an arc and use that as the edge rather than trying to grab this edge here. So we'll do that first. So on our, back on our CAD tab, got the arc command, and prompts down at the bottom for first point. Then it wants another point along the arc, so that's a good point there, and then I can choose this as my end point. So with those 3 points, it's able to draw an arc through there. So we'll take this kind of one step at a time here. Now at the other end of this bevel cut, again looking at top and bottom edges that we can select. So this can be our top edge, this again will be our bottom edge for this bevel cut here. But again, we've got this area here where there's this void where we've got no edge. If we choose this edge and then we go to connect it, we're going to end up with this connection that'll come down here and will be at a very steep angle, and it's going to straighten up, and again it might not be the best result. So what I'll typically do on something like this, so that I've got a nice continuous fixed angle, is extend these edges and we're going to extend them out to the end of the model here, so we'll be able to come in nice fixed angle, and then same thing on the other side leading out. So handy command for that on the CAD tab is this extend. So click on that, and it prompts you down at the bottom, select edge. This is the first edge I'll extend. And then you've got these different options down here where you want to extend this to. And easiest thing on this one might be, in this case, do the box option again and tell it to extend that line to this surface of the box. And then we can do the same thing with these other edges. Now I can hit enter and it'll repeat the same command, but for clarity I'll just go up here and click on the extend again, select edge, and then we can do B on our keyboard for box, or click right on here. And then I'm just going to hit enter that time, click on that edge, box, and extend it to there. So now we should have nice edges here that we can use to add our toolpath for that cut. So let's go ahead and do that cut first. So cam tab. So first got to pick our curves. In this case here I'm going to pick edges, and we'll start at this edge and zoom in here a little bit, and we're going to continue along this edge, and it highlights in yellow where the next edge that it thinks I want. So this is the arc that's underneath there, which I really don't want that arc. I want this edge here. So if I move my mouse and click when I've got this highlighted red, then it gives me that full arc that I drew in there. And then I do want this edge, so I can do end for next and next again. So that one's done, and then similar thing on the bottom, pick edges, start there. And then we'll click on there, and next, next, and next. So now we can go ahead and add a toolpath to that. Click on my toolpath shortcut. We're using cut type ruled, fix Z, because we're cutting this out of a flat piece of material. Engagement is what it uses to calculate the feed rate. So this would be from upper curve to lower curve, and then there's going to be a little bit of additional material after that, so that would actually be fine for this cut. And I'm going to do user piercing, tilted piercing. I'll go a little bit longer on my lead in, and we'll go ahead and click on our plus button, upper curve, and we'll start here, and we're going to end here, and we've got a lower curve. And then my lead in, so my red lead in line locks in at that location there. If that's the length of lead I want, I just hit enter. And then for the lead out, same thing, move my mouse around when it locks in at this 3 o'clock position, I can hit enter, and that's my lead in, lead out. I've got the overbox checked here, overcut box checked, but since this isn't a closed contour, it doesn't use the overcut. So you can see as I click this on and off, there's no effect on the toolpath there. And always be careful when you're doing open contour cuts like this that you have the toolpath on the correct side based on the direction of travel. So here, because we're essentially going counterclockwise, we did get kerf on the left that time. Sometimes you have to be careful with those open contour cuts. Based on the direction you go, you might end up with kerf on the right, which would be the wrong side. As you can see, the toolpath is now inside the parts, so that would end up being oversized. So just keep an eye on that anytime that you do any sort of open contour cut. Okay, I think we're good there. We'll go ahead and look at one of these other cuts. So we'll just go ahead and close this for right now. Now for this cut, again, we could choose this as our upper edge and this as our bottom edge. What can sometimes happen here when you get two edges that come together in one point is Stream doesn't know which way to project, so you can end up with some pretty crazy angles, shall we say. So easier way on something like this might be to pick the top edge, and then we can use the fixed option and basically pick 2 points to pick up the angle on that surface. So on this one I don't need to draw anything in, I'll just go back to curves and pick edges, and we're going to start down here, and we're going to go in this direction. So I want this edge, so I'll left click on that, and that's all I need for that one, so I can hit enter. And then we'll go back to toolpath and we'll add a toolpath onto this one. And we'll leave all these settings for right now. Just click on my plus button, upper curve, start point, end point, lower curve. I'm not going to do a lower curve. I didn't select a lower curve, so we'll just do none. And then we've got the lead in and lead out, which we may have to come back and modify this later once we've added our angle to this. Tool is on the left again based on direction of travel, so that's good. So to get the angle, because we're cutting straight down there, on this cut type, which is set to fixed, you can click on this edit button here, and you can either specify angles. You'd have to give it A and C, or you can do 2 points, which would be a little bit easier. So first point, I can find a snap along here, like if I do M for midpoint, I could try Q for quadrant. Doesn't look like there's anything particularly convenient there, so we'll do M for midpoint. And then if I do the P project option here, it'll basically go perpendicular to that lower edge there that I clicked on, and it picks up an angle of 34.14 degrees for that. Now this one is one that we'll probably want to change the engagement. So right now the engagement upper to lower, so it's calculating the feed rate from the upper curve to lower curve, and we didn't even select a lower curve, so it would essentially be infinite, so that probably wouldn't be very good. I would probably, you could either do tooltip to table, and as you change these red lines change to show the what it's going to be using to calculate the feed rate. So that would give us feed rate cutting all the way through the material, which is what we need. So we'll go ahead with that. Now my lead in here is coming in at a little bit of an angle, because when I changed the cut to that 34-degree angle, that lead in point stayed where it was. So if I want to change that, I can, on this leads area, lead in area, click on this edit button here, and I can left click and put my lead in like that. And just want to make sure that's going to be long enough that we get good separation down there at the bottom, which looks good. And then similar thing on the lead out, click on the little edit arrow here, and we'll left click here. I'm going to make this extra long to make sure that we get good separation across there. Could probably make that a little bit shorter. That should be good. Now we could do a similar thing on the other side, pick the edge, add the toolpath, etc. But for the purpose of this video, I'll show you another handy tool. So you can do things like copy and array and mirror toolpaths. So we're going to go ahead and we're going to mirror this toolpath. So back onto the CAD menu here, transform submenu, we've got the mirror option. So in any of these options, it'll give you some options down at the bottom as far as what you want to manipulate. So we're going to mirror, and down here at the bottom we're going to choose toolpaths, and then it prompts you to select toolpath. So I'm going to click on that toolpath. You can also draw boxes around things if you have multiple toolpaths that you need to select. Done selecting, hit enter, and then it wants to know what you want to mirror that toolpath around. And you've got your different options here. So for here, I'm going to choose 3 points, and I'll pick 3 points along the middle of the part here. So if we got the midpoint there, see, we've got a midpoint there, and there's probably another midpoint over here that would be good. So, and what's really neat about that is mirrors the toolpath, it also mirrors the kerf offset. So whereas this cut was going in this direction and it did kerf offset to left, once we mirrored that, we're still piercing here, we're coming in this direction, and it changes the curve offset to be on the right based on that direction of travel. So that's pretty amazing, really. I'm amazed by that. So got the first cut, second cut, and then the third cut. And we see down here this one's curve right and this one's curve left. Okay, so now we got this one here. Could do a similar thing on this one that we did on these cuts, where I could choose this edge here and then pick up a couple points for the angle, but we've already done that, so I'll try something a little bit different on this one. I'll use the project curve option here, so we'll go to close and back to the CAD tab. So we can use project and select curve. We're going to select this curve. We're done selecting curves, and again, you got different options where you can project things to. So if you want to project thing to a surface, and we're going to project it up to this surface here, and if there's an angle in the model that we could pick up on to know how to project that, we could click on that edge. Again, if we don't have that, we can choose 2 points, and we'll go from midpoint to midpoint here. You can see how it now projects that edge up to this surface. Now again, I could have done my CAD thing, drawn that in, but just trying to show you some different tools here that you can work with if you get stuck. And then if you wanted to, you could also project that down to the bottom of the model and use those as our top and bottom edges. So let's try that. So we're going to project, and we'll choose this, and done. And again, we'll pick points, or no, sorry, we'll project it to, we'll project it down to here. Now we'll do the 2 points, midpoint and midpoint for the angle. So let's see, if we measure endpoint to here, endpoint to there, we've got a 30-degree angle there. So now with that, I can go back and pick edges, and we'll pick that edge that we had projected up and hit enter, and then we'll pick this edge down here, and then we'll add a toolpath to that. So upper curve, start here, end here, lower curve, and then lead in and lead out. And then based on the direction of travel and based on the previous cut, or based on direction of travel, it went curve left. So we'll just, again, keep an eye on those open contour cuts. We'll go curve right on that. So, and then for the engagement, this tool to table carried over from the previous cut, so that will give me the same result in this case as if I chose upper to lower. And as you change these engagement choices here, you can see down here at the bottom what it's going to be using for the thickness of material to calculate the feed rate. So whether I do tool to lower in this case, tool to table, or upper to lower, I get the same engagement, so same feed rate. Constant, you can type in a number that you want to use, and then that's what it will use for the feed rate. So now I think the only thing we have left is the outside cut. And since the outside cut is just a vertical cut, we really only need to pick a top edge. So let's go back to our curves area here, pick edges, and I'll just start here and work my way around. I do want to go that way, so we'll do next and make sure we're going this way. So when I get to this point, I can follow this edge, and then this edge here, and we want to go this way, and we want to go that way, once you get all the way around and have a closed curve, it turns red like that. If things get a little bit confusing, Shift Z will toggle between solid and transparent model. So we're done with that. And we'll go ahead and add a toolpath to that. So I'm going to leave a tab on this part so it doesn't drop into the tank. I'm going to lead in from this edge down here, and we'll put our tab at our lead in lead out point down here. So we'll do our plus button, upper curve, start point, end point. I hit enter because I'm going all the way around this time. Direction that I want to go around. Lower curve, I didn't choose lower curve, so I'm just going to hit enter, and then lead in, and then lead out. Now generally on close contour cuts, it will get the kerf offset to the correct side. Now this is at a 34-degree angle because it picked up the basically the last fixed angle that we were at. So of course we want to straighten that out. Since it's doing fixed, it picked up that fixed angle from that earlier cut. So if I want to straighten that out, click on the edit, and then down here at the bottom, click on straight, and we can see that that is now vertical. And then we'll want to look at the engagement. Again, we didn't choose a lower curve, so upper to lower wouldn't be a very good choice here. So again, I could do tool to table, and then we see the engagement there is 1/2 inch. For the tab right now, so this one, the overcut does come into play. If I uncheck the overcut box, then right now the lead out is right along where I led in, and if I put a negative number in here, then we'll end up with we can leave a tab so the part doesn't fall into the tank. So negative value here, and you do have to take your stream width into account. So if I wanted a 10 thousandths tab and I've got about a 45 thou stream width, then I'd want to make this, to be safe, I'm going to make it 60. So we should end up with a, once we subtract off our kerf width, about a 15 to 20 thou tab there. That's a little generous. We'll make it 55. So that should be about a 10 thou tab. And that's just a question of whether we want to change any qualities on any of these cuts. And we want this to look very nice, so we'll go ahead and we'll set most of these to extra fine. So once you've got all your toolpaths on here, if things get a little bit jumbled, hard to tell what's what, you got the show all box here, shows all the toolpaths. If you uncheck it, then it'll only show the toolpath that you currently have selected. So then you can click up here and step through things and see a little bit easier which one you're looking at. Okay, so if we're good with all that, once you got your toolpath the way you like it, you can click on this Rapids button here. So we're not going to have a whole lot of things to worry about for tipping up this little guy here maybe, but a couple times I've done this, he lays pretty flat. But if we did want to lift up less, you can come in here, click on distance. On a particular cut, say going from this cut to this cut, there's not going to be much of an issue. You can click on this height button here, and when you hover over this, that's 1 inch that's shown there, that's 1 inch from the table, so 1/2 inch lift. So if I change that to like 0.75, be careful on that one, 0.75, then it'll do essentially a 1/4 inch lift going from here to here. Change a couple of these. windows. So once you've got your rapids the way you like it, so this button here is a button that I have customized, added onto my toolbar, so when I'm doing my development of a part, handy to be able to come in here very easily and run through my simulation. Okay, now you might choose to do things in a different cut sequence, but we'll just go with that. So I'm going to go ahead and make my CNC file. And then finally click on Create Part. You can click on the file name, it'll pick up the name of the original file. Click on OK, brings it out into the 2D area. So just so I don't forget, I'll set my 00 point on here in case I want to make my CNC file from the 2D area. And then always remember, click on this part button and make sure that that Z value there reflects the thickness of the material. And then we'll go ahead and save this. So we've got the IGEMS dig file. Okay, let's go ahead and go cut this. Okay, here we are out of the machine. I've got my 1/2-inch aluminum clamp down. This machine, we've got a fixture set up here at the 00 point of the machine. And when I put this material into the down on the table, I use these 3-inch spacers here, space this material 3 inches off the fixture here. And then with that, I'm going to go into IGEMS and actually tell it that we're going to use a work offset position to cut this part. Earlier, I had programmed it with the G92 position. When I got out there, I said, well, I'll just utilize the fixture and we can do a work offset. And work offset's really cool if you're doing a lot of repetitive work in the same location. And we've got a whole webinar that talks about that. So let's take a quick look at that and then we'll cut this. Okay, so here in IGEMS, one of the neat things you can do is you can set up a machine template that I've got here. So the red lines represent the cutting envelope for my machine, and we've got our 00 point down here. The grid pattern here represents the 4x4 inch job shop grates that we have on in the table here. If I'm doing a really small part and I want to center the part on the center of the intersection of one of these grids, then with that I can use this as a reference to locate the part here. So in case my tab was too small, I've kind of centered this on one of the slats here. And then when we set our 00 point, I've got it set up so it automatically sets the 00 point at the 00 point of the machine. And then when we create our CNC file, we have this box here, and we can specify that we want to use, in this case, the G55 work offset position. And with that, in the controller, it will look at our saved G55 position. So here in the controller, up here in this offsets area, we can have G54 through G59 used, and G55 we have set X0, Y0, and then the Z is set so that we're going to be 1/8 of an inch off the top of our 1/2-inch material with this value here. So go ahead and turn our pump on. Load our parts. Cutting edge is currently here. Part will be cut there. And we'll just wait for the pump to come up to pressure. Good. So we'll see how I did on my tab size here. That's not too bad. So, let's see. So there you go. Hope you enjoyed that. If you have any questions, can let me know. So there we go. Hope you enjoyed that and learned something. And if you have any questions, please let me know. Thanks. So there we go. Hope you enjoyed that. And if you have any questions, please let me know. Thanks.